Nothing more than just your voices. Okay, so I'm going to do number 6. Andrea had an issue with number 6. She said she couldn't do it, so you can check number 6 there on the page. So Andrea, what you need to remember here is that we have an AS. And in an AS, the difference between preceding terms will always be the same. That's what we call the constant difference. So it is T1 minus T2 minus T1, T3 minus T2. And this is what I've done. You just note that you use brackets so that the negative applies to everything. And that will give you the T in the end as 2x that you're supposed to get. Now you will see that that question says, show that T is equal to 2x. So you may not use the 2x to prove this. Your final answer should be what you see there. Then the second question says, write down an expression in terms of x for a common difference. So common difference we calculate by subtracting 2 terms. That one you got right. That is what you got on your homework as well. You got that right, as far as I can remember. Suggested ideas that you give you feedback when you come back here on Monday again. So you send me the homework, I have time to work through it and then give feedback because I can't do everybody's at the same time. And then the last one, 6.3, was calculate the numerical value of x if it is given that the 10th term is 108. So I start with 108 on this side, the 10th term. This is my first term. You can just write this in here. This is the first term. This here I got from n minus 1, which is 10 minus 1, the 10th term. And this value here, in this bracket, that is d. And then from there you can calculate the value of x.
I found now, so.
You see it? Okay. So even if you were in this class and you still want the video or the YouTube, you just send it to me, I'll send it to you. And you can check it again if you're not sure. Okay, the one thing we have not done with arithmetic sequences last week is arithmetic mean. You will see the formula there is extremely simple. It is like this: a plus x plus b, or a semicolon x semicolon b. So this is just the first 3 terms of an AS. So if I want to know what is the value of x, I just have to add the 2 together, divide that by 2, and that gives me that. Like we've calculated mean, that is the middle value. So calculating the arithmetic mean between 2 values, I add the 2 values divided by 2. So if I have an example of this, let's go with 3. Okay, just another one. If we have pluses in between, then it's called a series because we add them. If there's semicolons in between, it's called a sequence. But it doesn't really make a difference what you use where. Let's go with, don't copy this, like that. Okay, so I'm going to remove the one in the middle. This is the one I don't want here. So let's call that b. So how will I calculate the value of b? Adding these 2 together, 3 plus 11 is 14, divided by 2 will give me the 7 that goes in there. So this is what an arithmetic mean does. It just calculates a value in between. But you will see in the notes there that you sometimes have to insert more than 1. And to get it between 2 is easy. To insert an arithmetic mean between 2 numbers is easy. To insert it more than 1 in between them is slightly more difficult. But this is why I'm going to do number 10 with you. So check number 10 there on the page. That is on the second page of the Andrea. It says there, calculate 2 arithmetic means between minus 12 and 15. So this is the method that I would like you to use. So T1 is minus 12. T2 is what we don't have. T3 is what we don't have. And T4 was given to us. Can you make the connection from the question there to what I wrote on the board? So just to go back to the previous one, here we had to insert 1 number. Now we need to insert 2 numbers. So there's not a specific formula like that one for this. But we have the first term, we have the 4th term. So we can calculate with that information term 2 and term 3. Understand where we're going with this? So how do I calculate that thing? I use this as my nth term. So here's the formula again. Dn looks like that. Where Dn is 15.
So why do you use the fourth one and not the first term, like the negative 12?
I am going to use it, but I have the first term as A. A is the first term. So the negative 12 goes here. We know that n is 4. Let me just redo that. Times by the d value. So what are we doing here? We're using two known things. We're using the fact that we know the first term and we know the fourth term. And then I used this formula where Tn is 15, first term. Tn is always the last term, the one at the end. The first term is minus 12, and the only unknown there is d. So if I bring that across, it becomes positive, and that will give us 27, and on this side we'll have 3d. So to get the value of d, we divide by that, and that gives us a d value of 9. So how will I find the second term now? How do we go from first term to second term to third term, and so on? We always add the common difference, which is d. So if I take the first term, which is minus 12, then the second term would be minus 12 plus my d value. And that would be minus 3. If I want the third term, that would be the second term plus 9. And that will give us 6. You with me here? So if I want to insert one arithmetic mean, we use that formula, that's 1 plus 1, divided by 2. But if we have to insert more than 1, then we need to do this and say. If I want to insert 3, I will do exactly the same thing. I have the first one and I have the last one. And this applies to geometric means as well, but we'll get to that shortly.
So basically, if you want to calculate it, you just use the last term and the first term, basically.
Yes, that's all we need.
So if there was now like T10, for example, so that would be the last term, and I use that. So.
Yes. So we just use first term and last term, because in our formula we have last term, we have first term. We know how many terms there are, and that is why we can use this formula. Okay. Andrea, you sure?
Yes, sir. So basically just look for D.
Yes, that is to get D. Once I have D and I have A, I can calculate any term for that matter. I can calculate the 10th term now if I like, or the 100th term, or the 102nd term, whatever the case is. Let's have a look at question 11. It says there the sum of the first 10 terms. So I wrote S10 equals to 145. And the sum of the fourth and ninth terms is 5 times the third term. Sure. Sum of the fourth and the ninth. Check. Fourth. Oh, no, that's wrong. I'm adding the fourth and the ninth term. I'm not calculating the sum of the fourth term. Is 5 times the third term. So if you look at the words there and you look on the board, does it make sense?
Yes.
It says the fourth and the ninth terms is 5 times the third term. What formula do we have for what is the sum formula? Sn. I'm just going to write down the formulas here for now. Especially for people who has not been here, not watching the video.
Over 2 years, I know that.
Oh.
That was a little shady.
So I can stop picking on you now.
Yes,
Okay, I'll do that. I'll stop picking them. So the tens term is 145. What is the n value? 10. The a value we don't have. What is the n value? Still 10. 10 minus 1 is 9. So this will give us 9d. You with me here? So we're setting up two equations because we have two unknowns. We need a and we need d. Going across to this one, t4 will be a plus 3d. Do you know why? A plus n minus 1 times d. And n is 4. 4 minus 1 will give us 3. Okay, let me just, you can see there are question marks there. Not just you. Tn a plus n minus 1d. Here we dealt with s for sum. Now we're dealing with t, so tn. Okay, so the fourth term would be a plus 3d. This is this one. So how did I get 3? That is 4 minus 1. That's a good idea.
Oh, okay.
Are we getting there?
Yes, no, yes.
And then I do the same for T9. So what will T9 then be? A plus? How many D's?
8.
8. I'm just going to need some spacing, so I'm going to just move this away. Okay, so what do we need here? What will be the third term? A plus what? How many D's? 2D. 5 times A plus 2D. Sorry for squeezing that in there.
So that equals to all the 80s, right?
I can't seem to connect this, I don't know. Now if I simplify this one, I will get A plus A, which is 2A, 3A plus 8, 3D plus 8D is 11D, and this is going to be 5A plus 10D. So I'm just simplifying the two. I want to make either A or D the subject. Making D the subject is easier. I'm moving the 10 across. So that's going to be 11 minus 10 will give us 1D. And I'm moving the 2A across to that side. So that gives us 3A. Then this 3A I can substitute in there. We just use I substituted into D over there. Now I'm going to have only A.
So that's that being substitute 1 into 2, and then that's Thangasa's 1 and that's Thangasa's 2.
So this is 145 equals to 5, 2A plus 9 times 3A. 9 times 3A. So we only have A now. is going to be 29. 5 times 29. A. I got 29A, that's 2A. That is 27, that's 29A. What is 5 times 29? 150, 145.
Yes, sir.
145. So we have 145 equals to 145A. So that will make us A equals to 1. So all of this was done to get A. We still need to calculate D. So how will we get D? We have a value for A, so we stop it in here, or in the other one if you like. So D is equal to 3 times 1, which is 3. What was the question? The question was, write down the first 3 terms. So what is the first term? 1. What's the second term? 4. And? 7. Okay, there we go.
So that's basically like how making the Tn A equal to A plus N. That.
Yeah, exactly that, yes.
Like
So you can use the formula here.
Yes, sir.
If I use the formula to do that, I can go with 2. My A value is 1. 2 minus 1. Times the D value, which is 3. So there's your 4 spell. But if you have that, you can just add whatever you find works for you. Okay, then we're going to go to number 12. And the reason why I picked that one is as soon as you see the word proof, then everything goes wrong. Is that not so?
True, sir.
And I can read minds as well.
Yes, sir.
But you know that already.
Yes.
Prove that this is an arithmetic series. Why is it called a series
So,
now?
next question is,
Yes.
So how many marks would this count before you do like the sum, the proof, sir?
The proof.
Yes.
I would say that, yeah, you will see it's not that difficult. As soon as you know where to start, I would say about 5 marks.
That's a lot of marks, sir.
It is.
Okay, sir.
So, how do we, if I have the first 3 terms and I have to prove that this is an AS, how do we prove that something is an AS or an arithmetic sequence or series? What is constant? D. D. What is D? It's the difference between the second term and the first term, and the third term and the second term, and the fourth term and the third term, and so forth. So if I have to subtract this one from that one and that one from that one, and that should give us the same answer, and that would prove that this is a Tn. If I go back to this one, how would I prove that this is a Tn? Well, the fact that the difference from there to there is 3. 4 minus 1 is 3. 7 minus 4 is 3. 11 minus 4 is 3. Now 11 minus 4 is 4. 11 minus 7 is, okay, but you know what I want to say.
Yes, sir.
So how do we prove that something is an AS? We start with T2 minus T1. So I'm going to go with T2 minus T1. Now it comes down to you being able to do fractions still. And unfortunately, with this, you cannot use the calculator. Well, I'm sure you can see why you can't use the calculator. The unknown is the issue. So can you see what I've done here? It is T2 minus T1. So if you have to prove that something is an AS, it is T2 minus T1. Get a value. T3 minus T2, get a value. They must be the same in the end. Okay, so if I want to subtract 2 fractions, what needs to be the same? The denominator. That means I have to change the 3 and the 6 into the same number. I can change the 3 to become 6, or I can change them both to become 12, but go as small as possible. That makes it 6 at the bottom. So I multiply this one by 2. proper one there. And then with this one, nothing needs to change here. Just make sure that you have the negative applies to both the terms on top. So rather use brackets. So this is still over 6. That's going to be 4x minus 2x will give us 2x. This is minus 2 plus 1 will give us minus 1. So I skipped the step now. I did not calculate, worked out everything. 2 times 2x will give me 4x. Minus the 2x is 2x, and that I have minus 1. Plus the 1 will give us that. Now I need to go and do T3 minus T2. And the answer should be the same. Well, if not, then we've made a calculation error somewhere.
So we can't simplify that 6 and the 2, so we give it a, like, 1 over 3. That's wrong.
Yeah, that's very wrong. You can only do that if you can do it to both terms. So if this was, for instance, a 2 as well, then you can remove 2 as a common factor. And then that 2 cancels and makes that a 3. Okay, T3 is 2x minus 1 over 2. And that one is 2x minus 1 over 3. Let me just check if I have that. It looks like that. So to what are we going to change both of them now?
6.
To 6. So the first one is multiplied by 3. And the other one is multiplied by 2. So going with this, there's my 6 still. 3 times 2 is 6x, minus 4x is 2x. 3 minus 1 is minus 3 plus 1, or plus 2 rather, will give us minus 1. Can you see that the two answers are the same? 2x minus 1 over 6, 2x minus 1 over 6. So here's the conclusion. Are you still copying that? So here's our conclusion. Therefore, T2 minus T1 equals T3 minus T2. Therefore, this is an AS. An AS is short for arithmetic sequence.
So if they don't equal to each other, then it's not.
Then it's not an AS, because then we don't have a common difference. There's not a constant value or a constant difference that we're adding. So constant difference, common difference, same thing. Good with that? Okay, so the rest of that page I'm going to give as homework, so from 13 to 17. But we're going to go on to the next page to get to geometric sequences as well. I'm just quickly going to refresh your memory from what you, have you done this in class already?
Yes.
Okay, so this is just refreshing your memory. So for GS means that we have a constant ratio. We multiply by the same value. I just picked an easy one here. So in order to go from there to there, you see the cat already knows. The cat knows that you're here, and the cat, she's funny around cats. Okay, so what do we multiply this with to get to the next one? 2. So how do I get that value? R is calculated by using the quotient of T2 and T1. In other words, we're dividing them. With an AS, like the previous one, we subtracted the 2. This is also equal to T3 over T1. Not T1. T1. 2.
So it's never the first term on top, so it's always the
Yeah, it's never the first term on top. And then we have an nth formula, the nth term, a times r to the power of n minus 1. What is a again? The first term. R, common ratio, n is the amount of terms, and Tn is again the last term. So you can see we use exactly the same letters except for the R. We use the A and the N and the D and all of that except for the R is now common ratio or constant ratio. Okay. Now I'm going to do the proof of the sum formula. This is going to be for a GS. Jesse, so if you go and check the video from last week, you will see the proof of an AS is also on there. This is for exam purposes. Also again like 5 marks, possibly. So this is how the proof works. I start with Sn. Now since you have seen the other one, you will see that this is very similar to that. What is the first term? A. A is always the first term. So A is the first term. What is the last term? Check. Yes, Tn. Yes, the last term. No. So the last term is AR n minus 1. What will be the second term? How do I get from the first term to the second term? How did I get from 3 to 6? Times by 2. And then that one is times by 2 and so forth. So if I go to this one, this would be AR. What will be the next one? AR squared. So we start with the first term, multiply by R. Multiply by R, multiply by R. So then we get, what will be the second last term now? AR n minus 2. So where do we start? With first term, which is A. With last term, which is Tn. And then I multiply by R, multiply by R. Yeah, I just have to subtract really 1 R or 1 in the power to get the preceding one. This proof is not difficult. This is 5 marks given. For free. For you, for free. Now we do this. I multiply that top one by R. So if I multiply A by R, what will I get? I multiply everything by R. So if I multiply A by R, oh, come on! AR!
Oh, so is this like this formula thing we have to learn?
Yes, you have to learn this. I try to make it easy to explain to you. Start with first, end with last, and then fill in between. I know it's not that simple.
It's kind of confusing.
What is AR times R? AR squared. And so we can go on AR cubed, AR4, and so forth.
But so why we multiply by R? So, 'cause I'm confused.
This is the trick. Or this is the thing that we do to get to the formula in the end. Okay, so I'm just, with the other one we swapped it around.
So if I multiply with R here, then everything on this side gets multiplied by R also.
Yes, because what we do on the left hand side, we must do on the right hand side. My question to you is, what will be the last term now if I multiply the last term by R? What will the power of that term be?
In R minus R.
Isn't it AR2N?
In
Just N.
How's
in
Because if I multiply this, if I multiply R to the power of N minus 1 by R, add the powers together, that and that will give me 0, so I'm left with AR N. Does that make sense? So what will be the preceding one? If I add an R here in the power, I will get, AR n minus 1. So the second last one here is the second last one here, which is multiplied by R. So you can see this is going to require some practice, but once you've done this a few times, you have 5 marks for free. Now I subtract the two from each other. In fact, this one is easier than the sum formula for the other one. I'm subtracting the two from each other. So Sn minus Rsn. Now note the following. If I subtract, those two will cancel out each other. These two will cancel out each other. This one with the one that was there, this one with that one, and this one with the one that was supposed to be there. So what is left? The A and what else is left? What is that going to cancel out? A or N. Why is it the minus? Because we're subtracting the two from each other. See? So these will, that I've highlighted like this, will all cancel out each other. We have the first one minus the last one left. Then I remove Sn as a common factor here. And on this side, I remove A as a common factor. And then we have the formula, the sum formula for GS. So with a bit of practice, you can get this. This is applicable when the R value is between I should not use brackets here. This one is not on your formula sheet. This one is on your formula sheet. It looks like this. It's just swapped around. It will not really make a difference which one you use where in 99% of the cases. This is the one that's on the formula sheet. You see, in most cases they just swapped around, so it will not make a difference in which one we use here. But normally, this one is where R is bigger than 1 or R is smaller than minus 1. But don't worry too much about that. You can use any of the two. Use the one on your formula sheet unless there's something else.
So we don't get the mark for adding down the formulas.
I would say that you will get a mark for this line, a mark for that line, a mark for writing this down, a mark for writing that down. So 4 marks, and maybe if you write down both, another mark. But they will ask you to prove that either that one, it doesn't matter which of the two you have. If your answer comes out to this, you can just write down this one. Are we good with this? Okay, let's look at a few examples here. Number 18. So in number 18, it says a geometric sequence has a common ratio of 5. R is equal to 5, and a third term of 3. Determine the first term of the sequence. So what formula do we use? We only have one formula at the moment, or we have both, but we're not dealing with the sum of a series. So we're going to go with Tn equals to A R n minus 1. So what do we have? Check the board. T3, Tn. So this is 3. Do we have A? No, but we have R. Okay, let me just change that one. So So the nth value, the Tn, is 3, but the third term is also 3. So the 3 that I'm using here, this 3, is this 3. The fact that this is the third term, sorry, I want a different color. This is the third term, so that is the 3 that I have over there. This is the 5, the R value, there is the 5. And if we calculate it from here, that will give us 5 squared is 25, so A will be equal 3 over 25. Any questions? Now the second question is, it says, which term is equal to 15 times 5 to the power of 27? So we want to calculate, it was given that Tn is 15 times by 5 to the power of 27. The reason why it's given that strange, why I typed it like that, is that your calculator can't manage that number. It gives it as scientific notation. It doesn't work. So we have to work out which term that is. What do we have of this? We have Tn. A we've calculated just now. What is A? 3 over 25.
So you know about 18.1, so this is the first term of the sequence. So that means we just substitute there by in 1 minus 1. So if you understand what I'm saying,
No.
so. Or did you just leave it like this?
This is the first term.
Oh yeah.
A is the first, but you can do it like that.
Okay.
So if you go with T1, then it's A, that would be 5 to the power of 0, which is 1 anyhow.
Oh, okay, no, sir.
Okay, with me now. Good question though. So we have the first term as that. What do we have to calculate here? Oh, the amount of terms now. And we have the R value, which is 5, to the power of n minus 1. So n is the unknown. N is what we're looking for. Now we need to get rid of this. I need to make that the subject. What does making it the subject mean? It means we have to get that on its own. So I have to divide this in here.
So we can't simplify that power to 5 to the power of 27.
Check it on the calculator. This is what's going to happen. So I give it as a scientific notation. Can you read the digits here?
Yes.
Okay, 7.45 times 10 to the power of 18. So that doesn't help us.
So would it be wrong if I had to write that and round it off to the nearest decimal or something?
Yes, you cannot go and round it off, because that will then your answer will not work out. Now the problem here is that if you try to divide this in here, you will get a similar answer to that. Did you?
I got 3,000.
On the dot. Did you see?
No, I did it wrong. I did it to the power 2, sorry.
So if you divide that into this side, you will get a similar result to what we see there.
Yeah.
And that's not going to work.
Mm-hmm.
So what shall we do? Don't divide that into the whole one, just divide it into the 15.
Okay.
Take the 3 over 25, so it's 15 divided by 3 over 25. What will that give us?
125.
Now that is something that we can deal with now. So here's the 125, still times 5 to the power of 27. Equals to 5 to the power of n minus 1. Now what is 5, 125, 5 to the power of what?
Okay, so
3. Can you see where we're going with this now? So this gives us 5 to the power of 30. And if we take that across to that side, we'll get n equals to 31. So in most cases you can use the calculator, but when the number is given like this, there is a reason for that. So what does that mean? That the 31st term is equal to 15 times 5 to the power of 27. Good.
Yes, sir.
And
Yes, sir.
you're not saying a lot.
Yes, sir. I'm just.
Are you taking it all in? Are you absorbing this?
Yes, sir.
Cool. Okay, then we go to number 19. This one is similar to the example we've done of the homework that you struggled with, except now we're dealing with a GS. In a geometric sequence, the first three terms is t minus 4, t minus 3, t minus 1. Now it says they show that t is equal to 5. What do we know about a GS? The ratios are equal. What does that mean? T2 over T1. No, not minus. Now we're dealing with the ratio now. So T2 over T1 equals to T3 over T2.
So, just quickly. We have this 15 and 5 over what one? Is it the one?
What is 15 over 5? What
No,
one?
not 15 over 5, but this one.
The previous one. Yeah, what about?
Yes. Is that to the power 30 or
Yes.
what? 31.
The 30. But now, if I leave, oh, I see what the problem is. If I leave out the basis, I will get
No,
30.
sir, I need. What is 31? Is
Yes.
it like that thing to the power 31 or what?
Oh, no. N is 31. That means that the 31st term is equal to this. This is the, because the question was, calculate which term this is. And that's the 31st term.
Okay, I see now.
Cool. Okay, so back to this. So second term is t minus 3. And first term is t minus 4. Third term is t minus 1. And t minus 3. So what do we need to do now? Multiply it out. Cross multiplication, for lack of a better word here. And cross multiplication means that we're really finding a common denominator and get rid of it. So this is multiplied there and that is multiplied there. T minus 3 times t minus 3 is t minus 1 times t minus 4. Okay, so multiplying this out will give us t squared minus 60 plus 9. On the right hand side, t squared minus 5t plus 4. And if we manipulate this, take that across to that side, I'll get t, and this across to this side. So there's the t equals to 5.
So with the geometric pattern, so is the approach always to say like T2 over T1?
Yes.
So I always start with that.
And with an AS, T2 minus T1 equals T3 minus T2. So if the question was different, if this question was prove that this is a GS, then you will work out what this is, get an answer, work out what that is, get an answer. It will not work in this case, I'm just using it as an example. Then those two should be equal, that makes it the GS.
Oh,
Okay, so T is equal to 5, and that is what we're supposed to get. Now it says there, hence just means that after we've done all of this, so let's say you could not get t equals to 5, you can still do 19.2, where it says calculate the sum of the first 10 terms. So we have to calculate S10, I'm just going to write down the formula. And the formula, and again it doesn't matter which one you use, a r to the power of n minus 1 over r minus 1. We need to calculate the 10th term. So S10. What is the first term?
T minus 4.
Okay, but now we have to use the value of t now.
So now just put it into 1.
Okay, so let's write down the pattern here quickly. That would then be 1. And if we fill in 5 there, that would be 2. And if we fill in 5 there, that would be 4. So there's our pattern. That's why they gave you that t is equal to 5. So the first term is 1. What is the r value? What do I multiply 1 with to become 2 and 2 with to become 4? 2. So this is 2 to the power of 10 minus 1 over 2 minus 1. $10.23.
Yes, no.
Because 2 to the power of 10 is 1024. Minus the 1 is 1023. And this is anyhow 1, so 1023. So that means that if I add the first 10 terms of this geometric sequence, I will get 1023.
So that formula there on top, so we don't get it on formula sheet, so we have to.
No, you do. Check the formulas there on the first page. There. No, not there. No, yeah.
Oh, okay.
Actually, the one at the bottom.
Yes, sir.
This is the one that you get, but you can use any of the two. So if you use it the other way around, it will still give you the same answer, exactly the same answer. So it doesn't matter which way around you use this. Okay, that is for today. So I would like you to do the following. Just get a pencil here. So I have given you number 13. That's the previous page, number 13, 14, 15, 16, 17. So they will all be ASs. And then on the next page, number 20, 21, 22, 23.
So we must.
And when must it be in?
Yes, I will ask it again. So
Wednesday. So send it to me on Wednesday.
I mean, yes,
Email it, WhatsApp,
yeah.
Telegram,
Telegram, so no.
whatever you want to use. I don't care as long as I get it. Or even if you want to, you can deliver it by hand.